Hello and welcome to another edition of Turbo Delphi Demos. I'm Nick Hodges, the Delphi Product Manager, and I'm going to be showing you today some features of Turbo Delphi. Specifically, I'm going to start going through the very basics of the code and the coding language Delphi, or Object Pascal or some Delphi, that you do use in Turbo Delphi. So in order to do that, I'm going to create a new project called a console application. And a console application is the very most basic form of an application that you can have in Turbo Delphi. It basically is a command line application that runs inside what most people would refer to as a DOS window or a console. And the reason that it's going to be defined as a console application is because of this compiler directive, which is of the compiler directive app type, which tells the compiler to compile your application as a console application. Now, the compiler is the application inside of Turbo Delphi that takes your code and turns it into machine code so that it can be executed on your machine. You get to write in a high-level language, Delphi, and the compiler actually compiles Delphi down into assembly code. And assembly code is the set of instructions that the CPU on your computer knows how to execute. And so that's what the compiler does. So in this case, we're telling the compiler to create a console application. Now, the first thing you notice from a language perspective about this console application is that it's got a bunch of different words. Some of them are bold and blue. Some of them are just straight regular text black. Some of them are, as you'll notice, this kind of greenish color here. Or this is actually, I guess, teal, maybe, huh? And then there's some code here that is green and italicized. And then there's other words here again that are blue and highlighted. The blue highlighted words are keywords. Those are words that the language uses specifically, and that as a general rule you aren't allowed to use. For instance, you can't call a procedure begin, or you can't declare a variable named begin. Same with program. Now, every Pascal program has a single unit or a single text file that is the main code for your application. In this case, it's a file called project7.dpr. DPR, the extension, stands for Delphi Project File, DPR. DPR is the extension. And every Delphi project file will start out with the word program, and then that'll be followed by an identifier that will be the name of your program. In this case, Project 7. That name will also be the name of the executable file that the compiler creates. So so I can save this project, I'll save it in its own directory, Project 7. And now if I compile this project, if I go Project Compile Project 7, you'll notice now that a file is created called project7.exe. Let me hunt it up here in the directory there. You'll notice now, project7.exe. And if I run this application, you'll actually see a DOS window. You might not be able to see it on the Camtasia, I don't know, but it actually pops up a DOS window, and then the DOS window goes away. And that's, of course, because there's no code here. There's nothing that the application does, but it does create an executable called project7.exe, and that's based upon this word here. As you notice, this teal colored text is as I mentioned before, a compiler directive. The IDE recognizes it as a compiler directive because it starts with the open squiggly brace $sign characters, and that makes it a compiler directive. The uses clause defines other units of code that will be used by this application, and by default the IDE uses for you the sysutils unit, which contains a bunch of the RTL code. Then all Delphi applications have a begin statement and an end with a period, followed by a period statement, and that is the main program. All the code for our program will execute in between these two statements. And in fact, that's true of any Delphi application. Every single Delphi application has a main begin and a main end statement followed by that end statement is followed by a period that notifies the compiler that that's it, the program's over at that point. So anything placed in between these two lines of code will be executed and run. So for instance, if I type in a common command, write lin, and I type in hello world for the classic hello world example, and I type the words hello world will be written out to the console, and I'm going to add another additional readlin, which is a command waiting for input from the user so that the application will actually pause itself at that point, and then I can go run. I can select run here, and now the application will run, and it says hello world. The readlin is now waiting for me to hit the enter key, which I'll hit right now, and that disappears and it goes back. Just as an aside, a couple things happen here. When you run this, first thing is you'll notice that the IDE kind of changes and it goes to the debug layout here. You'll notice the debug layout, and there's all kinds of debug windows and debug information and whatnot here that occurs. And then the actual application runs, and here it is running. When I end the application goes back to the default layout scheme for you. And that's the most basic of code there is. Write line is a function that a procedure that executes by writing out whatever you tell it to write out to the console window. So we'll be using a little write line just to kind of do some output here to kind of show some of the basic functionality of the language. Now the first thing you need to be able to do when you have a programming language is you need to be able to declare variables. You need to be able to identify and lay out certain identifiers that will hold information. Down here I have write lin, and hello world is a string constant that I'm writing out. But most normally you would want to be able to declare a variable of type string, and in this case, in Delphi, we declare variable using the var block. So we type the word var, stands for variable, and I'll declare a variable of type string named s, and then I'll put a semicolon at the end. Now semicolons in Pascal are everywhere, and they are statement terminators. They're statement separators. They separate statements from each other. So all Pascal statements have to be separated by semicolons. Now a statement is just a chunk of code, and we'll get to that a little later actually. So we declare a variable s, and once we've declared the variable, we can set a value to it. So in this case I can take what it was, this constant expression that was inside, and I can inside the write line, and I can assign it to the variable s, and of course I need to separate the statement with the semicolon. And now I can provide the same basic functionality as before, but I've assigned the value of hello world to a variable, and I can write line out the variable, and now if I run the application, you'll notice the same thing as that happens. It says hello world. Now in Pascal, all variables must be declared before they're used, and they must be you can't declare them in line. They must be declared ahead of time before they're used. Delphi uses a single pass compiler, so all variables need to be, the compiler needs to be aware of all the variables types before you actually execute and use them. There's a number of basic types in Pascal. There's the integer. You can declare an integer. You can declare a double, which is a real value. It used to be called real in old Pascal, but now they're called double to line up with what goes on in the floating point processor. And extended. Those are some of the very basic types of variables, and you can assign values to them using code, just like this. D gets 3.4, E gets 4.5. Now, you'll notice that I'm using this colon equals operator on the assignment of a constant value to a variable. The colon equals represents an assignment, as I said, and oftentimes you'll hear people say gets. So this statement would be read S gets hello world. Now that's distinct from the Boolean variable type, which is a true-false value, and so that would be the Boolean operator equals sign, which would be result in a true-false statement. So you would say things like b gets 3 equals 4, and that would be a false statement. And then the equal sign there would be a Boolean operator as opposed to an assignment operator. Now, if you declare the language, of course, Pascal allows you to do basic mathematical and other types of operators on variables. So if I have two variables and I assign them two different values, I can then have I'll declare a third variable here, and I can add two variable values together. K gets I plus J. And now if I add a write-len statement, write-len is actually overloaded, so you can have it output almost any type of any type of simple data types. Now if I run, you'll notice that if I run the application, you'll notice that it prints out 75, which is indeed the value of 45 plus 30. Okay, so that's simple variable assignment. You can declare variables of any type, and later on we'll talk about how you can define your own types, and we'll talk about some of the more complex data types inside of Pascal. But for right now, we'll just deal with the very basic functions of declaring variables and using them. That is declaring variables and using them, and variable assignment. Now, of course, you'll notice that one of the very basic tenets of any programming language is sequence, i.e. you have groups of statements that are placed in order, and then they are executed in order by the code, by the compiler. The compiler compiles them, and they are executed in order. So, in other words, the first thing that happens when this program is run is the value of hello world is assigned to S. The value of false is assigned to B, because 3 does not equal 4, obviously. And then these numbers are assigned. K gets a value of the two additions, and it all happens in sequence. Now, there may be times when you don't want to have something happen in sequence. You might want to have something repeated. You might want to have something happen 10 times. And for that, the Delphi language has the for statement. It uses for, and you'll see that the live templates is popping up here in the IDE, and it's going to help me write a for statement. Now, a for statement allows you to iterate over a certain number, over some code, a certain number of times. And in this case, I'm going to iterate for I equals 0 to 10, and I'll take out this -1, which is part of the thing. And then I'm going to execute a line of code here that will execute 10, or actually in this case 11. 0 to 10 is 11 times. I'll just write out the value of I. So now, when I run this application, we should get from a series of numbers from 0 to 10 in the console window. And there they are, 0 to 10. And that is because this statement write-line here was executed right after the for statement. For I, it gets 0 to 10, do, and then the next, and it will do the very next statement right here, right? That's a for statement. Now, here's an interesting step. Let's say there might be a very common thing that instead of doing one thing in the do statement, you might want to do two things. So you might be tempted, for instance, to write out two different things. You might say, write out I gets, and actually I'm going to make this a write statement, not a write-len, and then it'll all go on the same line, and then write line 2. However, the do statement, you'll notice that there's a semicolon at the end of this line, which means that a statement is separated. So the do statement will only accept and do, the for do statement will only do this single line. If you want to bunch statements together into a single statement, you use what's called a begin-end block. Now, a begin-end block defines a single statement as a group of statements. The for loop construct takes a single statement after the do. By wrapping up these multiple statements into a single begin end block, you create a single statement altogether. Begin end blocks define single statements with everything else that's in between them. And you can even nest them together and nest them within each other, and the compiler will sort it all out. So now, if we run this, the application will display I gets and then for each individual entry. Okay, so that's one example of iteration. In the subsequent editions of these demos, I'll show different ways to do iteration in Pascal. But right now I want to move on to conditional branching. Sometimes there may be two different things that you want to have happen, depending upon the truth or falseness of a Boolean statement. So for that, the Pascal has the if statement, if-then statement. So if something is true, then execute a certain amount of code. So in this case, we'll just say, we'll declare s to be equal to some value yes, and then we can simply say if s equals yes, then we can write something out to the console, something simple like s is equal to yes. Okay, so now this line here will only be executed if this line is true. And of course, since we're setting it here, obviously it is. But for instance, if we were to change this line to this, then s is not going to be equal to yes, and therefore this line of code will not execute. And once again, notice that we've terminated this simple if-then statement with a semicolon. So now if I run the application, the line of code we were looking at will not be executed. But if I come back and I change this down to this, indeed this time it will be. You'll notice s is equal to yes. There you are. Okay, so that's conditional branching. That's an if-then statement. Now, Pascal actually has, the way I like to refer to it, Delphi actually has two if statements. One is the if-then statement, and the other one is the if-then, live templates are helping me begin, and they're helping me out a little more here, if-then else statement. And what that is code that will execute one or the other set of statements. So in this case, we can copy this code out here. I'll just put it here. Get rid of this, like so. And in this case, if s is equal to yes, in this case, it'll right line out this. But if it's not, it will write out. I'll just copy this to save a little time here. I'll put in not equal to yes. And so if this Boolean statement here is true, then this code will be executed. And if it's not, otherwise, else, this code will be executed. So now when we run the application, you'll notice that in the first time we do get yes is equal to yes. But if we come in here and change this so that it's not a true statement anymore, we get the statement s is not equal to yes. So that enables you to control the flow of the program based upon Boolean values. Boolean values, again, are true, false statements. Statements that either evaluate to true or evaluate to false. Now, that's about it for this session of Turbo Delphi demos. In the next session, we'll do some more advanced iterations. We'll do some more advanced branching and coding, conditional statements as well, and we'll continue. And then we'll probably step forward beyond that, start looking at some complex data types. But in this session, we learned to declare variables. We learned to do some basic variable manipulation. We can assign variables to do addition, subtraction on the integers and whatnot. And we did some iteration, and then we did some conditional execution, as well as just sequential execution. Okay, that wraps it up for this edition of Turbo Delphi Demo.